Hello friends, myself Amol Chavan and I am here to teach you engineering mechanics subject. Till now we have solved 5 questions based on the Lami's theorem and I hope you have understood each and everything. You have solved all the 5 problems, calculated each and everything and got the correct answers. Now we are moving to the problem type number 2, okay, which is based on the circular bodies, which is also called as the spherical bodies. So the next step is we are going to solve the problem based on the spheres or you can say a circular bodies. But now we have the basics of Lami's theorem. So initially we are going to take a problems of the spheres or a cylindrical bodies in such a way that we can easily apply the Lami's theorem. Okay, so initially first 2-3 problems are based on the application of Lami's theorem in the circular bodies. So now without wasting much more time, okay, we are starting with our first problem based on the circular bodies or spherical bodies. Okay, so now here your question number 1, okay, and in this question they mentioned that a sphere weighing 1000 newtons. So this sphere is of 1000 newton and you know weight is always acting vertically downwards, okay. It's placed in a range. Range means something used for the gripping purpose or fastening or tightening, okay. So this structure is nothing but a range, okay. So this 1000 newton sphere is placed in this range as shown in figure. So find the reactions at the point of contacts. So here we have to find out the reactions wherever the contact of sphere with the range surface, okay. We have to find the reactions at this contact points. Now the thing is that how to show the reactions and at what angles it should be, okay. So I already told you in case of equilibrium problems we have to solve we have to solve with the step number 1, that is drawing free body diagrams, okay. So here we will first discuss FBD. Let me clear this and I'll enlarge this so I can draw FBD clearly showing all the reactions. Okay, so now here as I told you, suppose if this is the center of the sphere, okay, center of the sphere. Why I am taking center? Because I already told you this is our first problem and initially we are going to take 2 to 3 problems based on the application of Lami's theorem in the what type of equilibrium of circular or spherical bodies. So now here I am taking a center over here for the sphere. Now I already told you this 1000 Newton weight is always going to act vertically downward, okay. So I am showing it over here, 1000 Newton acting vertically downward. Now the thing is that reactions. So reactions are always perpendicular to the contact surface. Perpendicular to what? The contact surface. Sphere is having 2 contact surfaces. First one is over here, okay, you can see here, and second one is over here. There are 2 what you can say contact points. So there will be 2 reactions. So first reaction perpendicular to the contact surface. So this is vertical surface. So of course perpendicular means horizontal. So this is reaction, let it be, this is reaction 1 and now this one, okay. So we have to draw it in such a way that the reaction must be perpendicular to this point, okay. So approximately I am drawing a line which is perpendicular to this contact surface. So this is R2. Okay, now you can see here there are 3 forces acting, okay. There are 3 forces acting. System is in equilibrium. What are the conditions for the Lami's theorem? First, it must be in equilibrium. So of course this is in equilibrium. Then second condition is what? 3 forces must pass through a single point, okay. So here you can show it over here, like if I extend this line of action of this R1, so it is passing through the center. If I extend the line of action of R2, it is passing through a center. So you can see all 3 forces are acting at a single point or passing through a single point, okay. So second condition is also satisfied. Third condition was what? they must form concurrent force system, correct? Now, three forces must form concurrent force system. So you can see here, all three forces are passing through a single point. It means what? They are forming a concurrent force system. Same time, they must have a same direction, okay? Either tensile or compressive, means either away from the point or towards the point. So here you can see all the forces are towards the center. They are acting towards the center. So they all are compressive, okay? Initially we have assumed that, okay, so these are in a compressive nature right now and acting towards the center, okay? So the direction is same for all three forces. Now the thing is that this is FBD, okay? So we have to draw it separately. So I'll just move it ahead and I'll make it smaller. Okay, so now here you can see, if I consider vertical and horizontal axis, I'll redraw the same figure, okay? If you want, I can shift it over here and I'll enlarge this. Okay. Okay, now coming to the FBD. So first I'll draw horizontal and vertical axis to get all the angles. So this is my horizontal axis and this is my vertical axis. Now I'll show first R1 because it is easy to show. Horizontal. Okay, so this is first force and this is R1 horizontal. Then the 1000 Newton vertically downward. So this is 1000 Newton. And finally the R2, okay, finally the R2. So I'm taking it at a certain angle. We'll see how to calculate it. I'll tell you how to calculate the angles. So this is R2. Now you can see here, as it is, I have taken all the forces and draw FBD at point what? Center. Center is related to be the C for the center. So this is C. Okay, so at center C, now three forces are acting. So they all are compressive. Now coming to the angle, so try to understand this here. See, the rule is like, see, there are different ways, different ways to find out the angle, okay, for this force and along this contact surface. But the easiest way I always find is what? The law of perpendicularity. So see here, these two lines, okay, these two lines. And if I draw perpendicular to these two lines, so you can see here, see this is horizontal, so I'll drop a vertical line, sorry. See, this is vertical line from this point, okay. So now this is perpendicular to the horizontal. This is perpendicular to the horizontal. And this reaction is perpendicular to this. Try to understand this. This line is perpendicular to the horizontal and this reaction is perpendicular to the contact surface. Now see here, contact surface and this horizontal has a 45 degrees angle. This 45 degree. Okay, I can show it over here. This is the contact surface and this is your horizontal. And this is 45 degree as given in the figure. So same angle can be obtained between their perpendiculars. So if I draw perpendicular over here, see horizontal, so the perpendicular is vertical, and for this perpendicular is like this. So this is 45 degree. See here, this is 45 degree. Okay, so this is called as what? Two perpendiculars always having what? Same angle. Okay, two perpendiculars always have a same angle. I repeat here, so this line and this line. Okay, for this line, horizontal line, this is the perpendicular. Okay, this one is the perpendicular, and for this range surface, the reaction is perpendicular. So if these two have 45 degree angle, you will get the same angle between the perpendiculars. Okay, so this is 45 degree. So now see here, now you can see in this figure, R2 is making 45 degree with the vertical. Okay, so this is 45 degree. This is 45 degree. Now it is very much easy to apply the Lami's theorem. We need total angle between the forces. Okay, so here if this is 45 and this is 90, so total becomes 135. So this angle is 135. Now this is 90 degree. It is directly by observation you can write 90 degree. And this one is again 45 plus 90, so 135. You can cross check 135 plus 135, 270, 270 plus 90, 360. So total angle is 360 degree. Now we have angles between two forces. So now we are going to apply the Lami's theorem. Okay, so you know how to apply the Lami's theorem. Known force is 1000, so I'll start with the 1000 divided by sine of angle between other two forces. So if this is 1000, other two forces are R1 and R2. So the angle is sine 135, which is equal to, now I'll take R1 divided by sine of angle between other two forces. So if I consider R1, R2 and 1000, so angle is 135. So sine 135. And the last one is R2. So R2 divided by sine of angle between other two. So if I consider R2, these two are the remaining forces. So 90 is the angle. So sine 90. So just by observation you can see here, this is very much easy to solve. Now see here, just by observation, if I equate this two first, then sine 135 and sine 135 will get cancelled. Okay, so I am directly getting R1 is equal to 1000. R1 is equal to 1000. Okay, and now I equate this two. Let it be 1000 upon sine 135 is equal to, see, I am considering this ratio and this ratio. So R2 upon sine 90. So you know sine 90 is 1. Sine 90 is 1. So here the equation becomes R2 is equal to 1000 upon sine 135, which is equal to, we'll go with the calculator. So here 1000 upon, sine 135. So which is equal to 1414.21 Newton. Okay, so here we have both the values. Now I write the final answers. R1 is equal to 1000 and R2 is equal to 1414.21 Newton. So these are the final answers, and both are positive. It means that the directions that we have assumed at the start, that is nothing but the compressive towards the center, are correct. So quickly we'll revise the question that we have solved here. Just go through it. They have said a sphere weighing 1000 Newton, okay, 1000 Newton is placed in a range. So this structure is a range and the sphere is placed in between this range for the gripping purpose, whatever it may be. Now 1000 Newton will act vertically downward. Reactions are always perpendicular to the contact surface. Okay. Then we draw the FBD, and this 45 degree we discussed in this part. Okay. So perpendiculars have same angle. Perpendiculars are always having the same angle. So just revise this concept, and then we apply Lami's theorem that we have already done in last 5 questions. So we got the ratios. First we equate this to 1000 divided by sin 135, R1 upon sin 135. The denominators are same, so R1 becomes 1000, and then we equate this ratio with this one, 1000 upon sin 35 is equal to R2 upon sin 90. We know sin 90 is 1, so we got R2 ka value, and finally we have both the values with us. So I hope you understood how to start with the problems based on the equilibrium of sphere. Okay, so this is a very easy example, but still you can see here this question was asked in the SPPU examination, okay, December 15, and it is almost for the 5 to 6 marks. Okay, so guys, there are few more questions which are very easy, okay, and you can secure good marks in the engineering mechanics. Just follow all the problems that I'm solving over here, and I guarantee you that you can secure a really good marks or maybe out of marks in the engineering mechanics for the end semester examination. So now, without wasting much more time, now I'll proceed for the problem number 2. Again, it is based on the cylindrical or sphere bodies, and we are going to apply Lami's theorem in it. Okay.